Okay, so thanks video team for fixing this. So that was very helpful. And now, a few minutes late, but we just, do the same talk a bit later, same 20-minute slot plus 5 minutes Q&A, is Quickwit. François, welcome.
Should I take it? Is it sufficient? Or?
Oh, you don't have a microphone yet?
Yes, I have.
Okay.
Should be okay.
Yeah.
Okay. Hi everyone. I'm very happy to be here. Thanks for having me in this room. We have been working on observability since 3 years at Quickwit, and I would like to present here what we have done during these 3 years, the outcome of it, at least. First, I will introduce myself a bit. So I'm François. I'm working on the core engine of Quickwit, which is a search engine. I'm also the co-founder of Quickwit, and I also work a lot. I'm working a lot on the Grafana data source pooling that I will show you in this presentation. So for this, for the agenda, I will start with by taking a step back, a short one, and then we'll talk about the problem of cardinality that we can have with metrics. And then I will show you, very briefly, the engine of Quickwit and how it works. And finally, I will show you a demo of Quickwit working in Grafana for application monitoring. So let's start by taking a step back. So I'm showing this graph. It's not mine. This diagram is from Ben Siegelman. This is a Googler who works on the distributed tracing Dapper, software Dapper, when he was at Google. And he co-founded also Lightstep, which is a company doing observability and monitoring stuff. And I kind of liked this diagram because it summarized all the complexities, the intricacies between monitoring and observability, and the different signals that we can get from our applications or our servers. So at the bottom, you have the three signals, or the three pillars. It depends on how you call them: traces, metrics, and logs. And generally, you store them in different databases. Metrics, you store them in time series databases because you want something optimized for it. And it can be very optimized for this kind of data. And for trace and logs, it depends. You can store them in a search engine, or you can store them in dedicated storage. I'm sure you know Tempo and Loki for logs and Tempo for traces. And on top of it, you try to build your monitoring software with alerts on metrics, or could be on logs, or even traces if you can. So let me talk a bit about how the problem of cardinality here. At the bottom, you can see that metrics goes always into the TSDB, but you can also put some traces information into your TSDB. But in this case, you need to be very careful about what you did, because in traces, you can have a lot of labels, and you can be very, very accurate about what's happening. So that's why I just want to stop there a minute. When you want to monitor a distributed system, and we all generally have that somewhere in our job, they can fail for various number of reasons, even for a tremendous amount of reasons. And so you may want to label everything. Like if you have a software that is deployed with different versions, you want to have this version label. Same for the host. Same for the customer ID. If you are a SaaS, for example, you can have thousands of them. And you want also to monitor your services, your endpoint. In summary, your cardinality will explode, and this will be a problem for your time series database. It's a problem. It can be either a performance problem or a money problem, because if you look at Datadog pricing, for example, you will pay $5 for 100 custom metrics. So if you want custom metrics, because that's it, here you want something very specific to your business, and in this case you will pay. It will cost you a lot. So generally, you don't want to have all those labels on your metrics. you want to control and just keep a low number of them. That's not the same for traces. In general, traces, you want to keep everything so that you can dig into really understand the full trace. Each unit of work in your software, you will be able to understand for each customer, for one customer particularly, for one request ID or for one user ID, you will know what happened in your system. So generally, you keep everything in your traces. And that's what I will talk about today, and that's what Quickwit is for. So Quickwit is an engine that is storing logs and traces, and particular traces. It does not handle metrics. And it is a bit different than other search engines in the sense that we decoupled compute and storage. So we have the same approach as Loki and Tempo on this, that cheap storage is great. If you use an object storage, it's also very reliable, so you don't lose your data, and you have all the benefits of decoupling your write path, your read path, and it's really great when you want to scale to a lot of data, and that's the case in observability. And last point is that we worked on the search part a lot so that it can stay sub-second even if all your data is on object storage. And I will explain how it works very briefly. So the engine architecture is quite simple. It's globally the same for this kind of decoupled compute and storage architecture. You will find the same for Tempo, for example. So at the middle, you have your object storage, where you store your data. This is the source of truth. On the left side, this is the write path. And on the right side, this is the read path. So on the right path, you have your incoming JSON documents, could be traces, could be whatever. And you have your indexer that is running. And each 30 seconds, typically, or each 15 seconds, it will build what we call a split in Quickwit. This is a file where we put all the data structures that are used at search time. So it's it's several well-optimized data structures to be searchable on object storage. So we create them, the indexer creates them, and then upload it to the object storage. So you will have a bunch of splits that are put on the object storage each 30 seconds, for example. And each time you put this split, you also put one row in a metastore. It could be a PostgreSQL database, or it could be just a JSON file stored on the object storage. So we will add just the metadata of the split in it. And once it is inside the metastore, like the metadata of the split that was uploaded on the object storage, then the searcher is able to search it. So you have this nice decoupling where then if you want more searchers, you just have to increase your number of searchers. You can even shut all of them down. That's not a problem. So that's for the high-level view. To understand why Quickwit is fast on object storage, I have to show you also how a split is made. This is an interesting part because it shows you also the different data structure that we are using, and it will help understand how we can achieve fast search later on. So you have basically 3 data structures in the split, and one thing that we call a hot cache. The first data structure is the doc store. It's row-oriented storage. So if you have a document ID, we will give you the whole JSON document. The second data structure is the inverting index. So in this case, if you are looking for a user ID, request ID, or a keyword, it's optimized in the sense that if you give a user ID, we will retrieve immediately the list of document ID that contains this user ID. So it is very fast, and then you just have to retrieve a document from the list of those document IDs. The third data structure is the columnar store. So here it's for doing aggregations. If you want to do analytics on your logs or traces, we will use this columnar store. You can have a lot of columns. You can have sparse columns. It's optimized for that. And the last part is what we call it's a split footer that we keep in general in the memory of the searcher because it's very, very small. I put it 0.07% of the size of the split. So it's very, very small. So for that, it's cool because you can always keep it in your cache on your searcher. And in this hot cache, you will find like all small data pointers to the other data structures. So that when you make a search request, you will need only to make 1 or 2 requests to your object storage to find the response. So that's why I said when we optimized Quickwit for object storage, it's because of that, because we optimized those pointers. We put that in one footer that we can keep in cache. So just the next part now, I will explain you a bit how spans are stored in Quickwit. Okay, I have only 8 minutes left, so I need to speed a bit. In Quickwit, you can model things as you want. You can put any documents. But for span, generally, you want to stick to the OpenTelemetry data model. So what we did for this demo is that we used the data model based on the OpenTelemetry data model, while you have a bunch of fields that are always there. And you have also some dynamic fields like resource attributes and span attributes. All those are very dynamic. So I put some random examples here where you can generate like random keys and random fields. And here the nice thing is that Quickwit is also schemaless, so that we can store like in the inverting index and the columnar storage, we can store all those dynamic fields without declaring which fields you have or which you don't have. It will index everything in the inverting index and in the columnar storage. So it's nice when you don't know in advance all the attributes that you have on your spans. So it's time for the demo. So for the demo, I prepared like a demo for application monitoring. So my first problem was generating spans traces that are understandable for this kind of goal. So I discovered recently a tool which is an extension of K6, which is like a project from Grafana for testing, for load testing. And there is a nice extension to generate traces. I will show you a bit how it works. And then I deployed a Quickwit cluster on Kubernetes, and I did a Grafana instance to show you the result. So a word on the XK6 extensions. It's a nice extension you can declare some spans, like here I put some services like shop backend as SQL service. And you can declare whatever you want, so it's a template, and then you can say, you can set the cardinality, you can set if you want some random attributes, so it's pretty nice to stress test and see if your engine can handle high cardinality fields, can handle like many random attributes, so it's pretty cool. So let's do the demo because I prepared, it's live. Can you see it? Maybe I can zoom it a bit. So here I'm hitting our Kubernetes cluster and the index in which I'm setting traces. So we have approximately here now 341 million spans. So if I do a refresh, you will see this number moving. So now we have 355 millions of spans. So great. You can see that the uncompressed size of documents that are ingested in Quickwit have around 200 and have almost 300 gigabytes of size, and that it's less, we compressed data a lot in Quickwit. So here it's around, you can divide by 7 on this example, the size of data ingested in Quickwit. So here, the size of published splits is the size that is taken on the object storage by Quickwit. So what can we do? So we are sending a lot of traces just to confirm that it's live. So here it's just a dashboard based on Quickwit Prometheus metrics. So it's live. I launched it, I think 6 hours earlier today. So I'm just sending traces at 11 megabytes per second. That's not huge, but it's already pretty decent because it represents around 1 terabyte per day. And you can see that it is running with only one indexer, and we have one indexer that is not really doing a lot of things. It is using between 1 CPU and 2 CPU here. The spikes are due to the compaction that we are doing because Quickwit generates a lot of splits, and so we need to merge them. So that we reduce the number of reads that we will do on the object storage. So great, it's working, it's live, and I can show you that we can search traces with it. So let's have a look. So I'm running a search query on all the documents. So you have a lot of them here. You can see that per minute here you have 1 million spans. So that's a lot. And we can focus like on maybe I want to remove Quickwit traces. It should work. It's okay. It's service name, I think. Okay, great. So here I'm sending Quickwit traces in Quickwit so that we can monitor our own cluster with it. So now I'm selecting only the traces that I'm generated for this demo. So for example, we can look for query articles. So here, for example, what I can do is focus on one span ID. So as we have an inverted index, you can look for very accurate attributes. So here I took a span ID, but I guess we can do this on another. Let me check. I need to check the article to cart. Okay. Okay. So now I want to focus on this one because I added on this span particularly a high cardinality field for the demo. So you can see here that you have this random attribute with this random value that is here. So I can focus on it, and very fast I will get the results. You can see that this attribute value happens only very rarely, and it's with a search engine it's even faster when you have this kind of queries. So that's nice to search through spans, but generally you want to dig into one trace particularly. So you can use a Jaeger plugin that is pointing at Quickwit cluster, and it will return all the spans for the given trace. So it's easy to go from one span to the whole traces. But usually you want more from your data. And by that, I mean you want to monitor your services. Looking at one particular span is very nice, but when you know what you are looking for, but when you don't know, it's better to build this kind of monitoring dashboard. So here, okay, I will try to go a bit earlier in the past. Yeah, good. So I have set different panels. The first one is like a data histogram, and I'm counting HTTP requests. So for counting HTTP request, I'm using span attributes. I can show you that. So here, I'm saying I want all HTTP requests. So I'm using like the OpenTelemetry semantic for that. And I'm saying, OK, I don't want all other spans. I want only those ones who have at least one HTTP target. And here, in the second panel, I'm doing like a group by status code. So I'm using, again, like a dynamic attribute that is the status code. And I'm doing a group by on it and building this data histogram. This one is a bit the same. So here, instead of doing a group by on a status code, I'm doing a group by on target. So if you want to monitor your endpoint, that's useful. This one I can show you a bit more, because here it's not the count. We are computing the sum of the duration of each span. So I'm doing group by on each target, and I'm summing all the span duration. So you have a good feeling about the time taken by each of your target, each endpoint. But that's not enough, right? You want something that is more useful. It's nice to see this, but it's not enough to take a decision like, is there a problem or not? The last one is the P95 latency panel is more for that. So you can see that you have a nice smooth latency, P95 latency on all your services, except for this one. This is normal because I sent some traces with different latencies. So we will dig into that. So we know that maybe there is a problem here. The panel average latency here is just the average. I think you understand that. And this one is also interesting because I'm sending spans from two virtual data centers. So one is CDG and one is BRU. And so you can see that most of the spans are coming from CDG here. So for example, if we want to dig into like why there is a problem on the P95 latency, and I will stop after that. I will just show you that you can add your query here and say, OK, I want to look at all the spans that are over 1 second and 1 second, 0.1 seconds. And so you can see that only the endpoint articles to cart is problematic. You can see that, hey, maybe there is a problem in this data center because you have suddenly more requests here. And of course, if you go up to 2 seconds, then you see that here the color has changed, but it's coming from this data center. And if you want to dig into one particular traces, you can open like and have a look at it. So that's it. I think I will stop there because time is up. If you have questions, come and see me. And we will be happy to answer them. And also I have some stickers and hoodies, so don't hesitate. I'm happy to give you some.
Take one question.